All right, welcome to the Code Presents presentation of AI-assisted software development, a practitioner's view. My name is John M. Miller, and I'll be guiding you through this presentation today. About me a bit, a software developer and architect with code staffing. I've played roles of developer, architect, DevOps engineer, platform engineer, test architect, release manager, and trainer in the past, among other things. I'm currently working on projects for code staffing from logistics and lead management. And I am the founder and contributor to the Practitioner View blog, and there's a link for that there. And my email address is here if you have a need to contact me after the presentation. So, Code, who is Code? Code is a custom software development company, a stack augmentation company, Code magazine for software developers, and training like this webinar. We've been in business for 30 years and just hit the Code magazine just hit its 25th anniversary. You can visit the website at www.codemag.com for more details. At the end of the presentation, you'll see these links again. Visit the link on the left to complete a survey about this webinar. Someone in the office will pick one name from the completed surveys and will contact the winner to get an Amazon gift card. Visit the link on the right to sign up for a one-year free digital subscription to Code Magazine. You can also share this link with friends and colleagues. So let's talk about the session itself. So this session is to provide an idea on how you can be more productive and efficient using Copilot for software development. We're going to cover this in three major sections. The first section is kind of a setup where we're going to talk about managing context, which is all about controlling the AI output. And I'll give you some ideas on how you can fine tune the AI to give you to deliver the content that you actually are trying to shoot for. And they'll follow that up with some case studies, which are reports from the field about success using AI for software development. Then we'll get into some demos. I'll talk about reviewing existing code, which is how do we understand a code base, how to generate some documentation, so different types of docs that we can produce, generating test automation, creating different types of tests, generating code for different reasons for both addressing tech debt and feature debt, and then managing change, which is how we can use AI for helping us with commits, code reviews, issues, etc. Then we'll finish up with a small bit about bias management and how to keep AIs honest, and then some future considerations or things that you might want to think about. So let's get started. Managing context, controlling the AI output. In this section, I'll expose you to the range of options available for managing context. Well, I won't cover every option that I show on the screen, but you can use this information as a guide to your own exploration. So, managing context. What is the importance of context? What is context and why do we need to manage it? So context is all the information that is specific to your particular request that the AI can use in terms of building its response. So that context can be the files that you have open in the editor. It can be context that is defined in files that Copilot will read when processing a prompt, and it can be other things as well. We want to be able to manage it because the more context that we can give to to Copilot, it's generally better, and it's generally able to produce better output given more context. So context is kind of additive, which means as you work in the chat window in Copilot, it will add all the context that it's achieved so far and any additional information that you give it going forward in that session. Once you close the session, then all that context disappears and you can start fresh. The context will default to the files that are open in the editor, but you can add additional context, which I'll talk about in a second, and you can define context in a more global way as well. So let's talk about adding context. And so these are some of the ways we can add context, and let me show you this in Visual Studio Code, and we'll be using Visual Studio Code and Copilot for all of the demonstrations in this session, but different IDEs support these same kinds of features, so you'll probably be able to find this wherever you're working at right now. So here we're talking about choosing context. If I say I want to add context to my session, it gives me a whole range of things that I can select from. You can use images from a clipboard, instruction files, which we'll talk about in a second, MCP resources, which are a way to make things more interactive, a screenshot window, a source code control, problems from your problems window. Notice I've got 34 problems here. I could add that as a context for my session. The symbols from your from your application, or a number of predefined and extension tools that you can take advantage of. So when we talk about the built-in tools, these are a list of what those tools are, uh, and basically we can get to those through that tool menu from Visual Studio Code. So if I choose tools here, I can see a list of all the built-in um, the built-in tools, as well as the add-in tools here. And as you add extensions into Copilot, these get added here, and any of these can be used as a part of um, as a part of your context. And for example, here, this is Azure Terraform best practices. So if you include this in your context, all of these best practices will be included, and therefore anything that you do related to Terraform would be subject to inspection by these best practices. A couple of them that I've used quite often, I use the Codebase um, tool quite often to make sure I'm including the entire code base in the context. I mentioned the problems one. Another one I think is interesting is the uh, terminal last command. What this will do, it will then make whatever the output of the terminal window is a part of the context. So if there's an error message there, or something that's unusual that you want Copilot to take a look at, you can just reference that through this and not have to copy and paste. Terminal selection is something that you've actually selected out of that output, and then test failure would be what it does is it looks at the last text execution and the failures of those tests and tries to address those failures. And then for the extensions, there's, as I showed you, there's more of these than we could list on a single slide like this. But these provide lots of different functionality. For example, here you could review the unstaged files, you can review the stage files, you can do a review of the code that's current in the current code base, etc. So moving on, let's talk about instruction files. These instruction files act as a guide for Copilot, and you can locate them in two different places. You can put them in the .github folder in the instruction folder, and then any instruction files. And these instruction files, you'll see, are just markdown files. It's just text that you're providing as if you had typed it into the chat window. And they're all scoped to the project, which means that they're checked in as a part of the source control. You can, when another developer opens up that project, they will have those same instruction files available to you. And the benefit, I think, of being project scoped is it's a part of the project, and you can use it to define standards and practices that apply to this project specifically, or include generic ones that apply to multiple projects, but each one has to have a copy of these instructions. You can also put them in the user data folder, and these would be user scopes. So if you have instructions that are specifically tailored to how you like to work, you can put them there. They will not be committed to source control. They exist only on your local machine. But the benefit of those is that they apply across the board for any session that you have in VS Code. So these instruction files, what do? Well, they help understand the project context and requirements. They help you generate consistent high quality code. You can provide templates and other things that you'll see. for how that code should be built. You can helps you follow best practices and coding standards, and you can adapt to specialized tools and workflows. So let's take a look at some of the examples of these. I'll be providing all of these examples to you after the session, so you'll be able to use these and incorporate them into your own projects or modify them as you see fit. So project context, this provides project-specific guidance, project overview, a technology stack, and the file structure. If I go back here to code, I just want to talk about the instruction files. So let me show you, I have these stashed. So let me go ahead and get the stash and apply it. So if I go to my stash and I say I want to apply a stash, I have instructions here. And you can see that this has brought down about 20 files or so of GitHub instructions. And it also has a README file here that was created by AI that documents what the different standards are and what the instruction files are doing for you. So the first one we want to look at is the project instructions. Let me get us a little more room. So you can see, as I mentioned, they have a project overview where you can describe what the purpose of the project is and any high-level requirements that you want the AI to be aware of. Here's the technology stack. Here's the file structure, and this file structure was generated from the actual file structure of the project. So one thing about this project that I'm working on here is it was an early version of a production application that we built at code. It was created by a junior developer that's no longer with the company. And so it has a lot of, I would consider it a target-rich environment for improvements and refactoring. So it will provide us a lot of input in terms of how we move forward. The actual implementation is not really that important for this presentation. I won't be building the app and running the app or making modifications and running them. I'm really intending to try to show you prompts that you could use on your own code base and these instruction files on how you can use this to adapt or improve your generated output. All right, so let's go back to the slides and let's move on. So here are some code quality instructions. We can do things like code templates, error handling guidelines, validation, testing, integration, and API documentation. If we take a look at some of these, and I go back and say, let's take a look at the view templates. So here are code templates instructions, and this file basically just contains a list of various code blocks. So this is a nice feature that we're utilizing of Markdown, is that we can have textual-based information as well as we can provide view code. And here's a view component template. So it would describe how you would expect a view component to be defined. Here's an example for a view store. And another example for a utility function, and you can see there's many more templates that are defined here in this code template instructions. In terms of error handling guidelines, we can take a look at the view error handling instructions, and we can see that is another template, and it describes how an exception would be dealt with. We have validation guidelines that here. It describes various implementations of validation for various different purposes. For example, this is a password validation. We have date of birth validation, email, etc., as well as some component, some in-field validations and some custom validations as well. And again, the point of these are that when you're asking Copilot to generate a custom validation rule, it's going to follow this template as a guide to the actual coding. All right, so moving on to the testing guidelines. So this basically defines like things like unit test templates, integration test templates, And then here's an end-to-end test template. A PNS store test template, a router test, etc. Lots of different templates that you can define for when it's creating different objects. And then we have the cloud integration. Where is the? Well, I don't see that. Here we have integration documentation for. Well, anyway, we'll move on to the last one here, which is the API documentation. So that's, and here we see the API documentation for JS doc standards for view components, API service documentation, etc. So those are some of the templates. Let's move on and talk about coding practices and coding standards. So we have a style instructions. Here, notice this is not a template, but just a set of points that that the Copilot should take advantage of. So it says that when you're dealing with view components, you want to use compositional API. You would prefer single file components, so each of them in their own view file. Use TypeScript for all component logic. Follow Pascal case for component names. Use camel case for props. So here you see a multiple different kinds of guidelines for creating it, and you could certainly add anything that's specific to your environment to these kinds of instructions. And then the tools is up here, and these are applicable. So this is an example of a specific rule that you can define. So here is what's called an Azure rule with the @Azure sign, and this rule says it basically tells the Copilot that when you're doing actions related to Azure, use the Get Azure Best Practices tool, and that what that contains is best practices for dealing with Azure resources, and it will provide guidance related to those best practices. All right, so moving on then. Specialized workflow and tools. This allows you to do things like, if we look at the command instructions, here, these are commands and scripts you can define. You can basically list out a bunch of commands that you think are useful as part of how do you build and run your solution. And that will provide a Copilot with some guidance in terms of how to do specific functions. And what we'll see is that in agent mode, it will actually prompt you to run these commands in order to accomplish particular tasks. And then finally, we talked about the tool instructions already. So let's move on to updating instructions. So here's something to think about. You know, these files, as we're talking about, these instruction files, they're committed to source, but there's there's nothing that's gonna, where they're not updated unless you actually take action in order to do that. So if there's a new standard, a new practice, or if a standard that you've used has become obsolete, or there's something that's preferable to that over time, those instruction files will start to, I guess, decay and become less and less relevant. So you want to try to keep your instruction files updated with changes as they come along, both in the tooling that you're using as well as your coding techniques that you're taking advantage of. So let me show you a prompt that might help you with this. And if I take, so the prompt was this, and let me go to the command, and in the chat window, I'll just paste this in here. And so it says this prompt says to review the instruction files in the GitHub instruction folder for errors and omissions. So what this will do is it will actually take its own knowledge base that it's built up, and it will compare that knowledge base against these instruction files. And if it sees things that are obsolete or are incorrect, it will suggest modifications to those instruction files, which is a great way of keeping up to date on the latest code implementation strategies and techniques. And then you can in turn use those when you're actually asking a Copilot to generate code for you. Um, now, keeping your code compliant with instructions. In addition to asking Copilot to update the instructions, you can ask Copilot to actually take a look at your code base and measure those against the actual instruction files, and report back on what deviations or things that it finds that it don't comply with the instructions. Um, I'll show you an example of this a little bit later in the presentation. Um, so we'll stick with this for now. And these are some of these context. Notice here's the context rules. Here's some of these other kinds of rules that you can create and provide additional context inside of your instruction files. All right, so let's go over just a few case studies in brief, and here's some reports from the field about how AI has improved the ability to write software. There's 4 of them that we're going to be talking about: a GitHub Copilot study, a Redbook analysis, a developer experience survey, and an Accenture case study. So the a Copilot research study from 2022, it found that developers using Copilot completed tasks 55% faster, and that 88% of the survey developers reported higher productivity, which led to improved code quality and reliability due to fewer manual errors. I think this is a interesting study. One of the things that occurred to me when I was looking at this was that if 88% of survey developers reported higher productivity, what was wrong with the other 12% that did not report any higher productivity? And I had 2 thoughts on that. One was maybe the developers were so new to development and so new to using AI tools to assist in their development, they just did not see they were not able to find a way to make it more productive. And the other would be is, let's say that maybe the developers were at the more experienced type and working in a code base that they understood very well. At that point, it may be that the AI tools weren't able to suggest much in terms of improvements. The next one, this Redbook analysis, organizations using Copilot saw a reduction in code review cycles and bugs, and that the code suggestions help standardize those code bases, improving maintainability and reliability. I think this this improvements of maintainability and reliability is key here, in that by applying these standards that you can customize specifically for your project, you're going to be producing. It's easier to produce code that's compliant with those standards, and so that will help all of the developers to get on the same page, and I think help make sure that the code gets implemented in a consistent fashion. The DX survey findings: 96% of developers reported faster task completion. 73% said Copilot helped them stay in the flow. Staying in the flow, I think, is a major benefit of using AI tools in your development process, because up into AI, your typical workflow would be you would you write a piece of code, you would run it, it would almost always fail. You would then look at the error messages and would search through Google or Stack Overflow or some other resource on that particular error or that particular technique. You would get some ideas. You go back to your code, you change the code, you run it again, it still doesn't work, and you would go back to those same sources and try again, constantly switching back between writing code in the IDE and researching the issues that you're finding along the way. By staying within the IDE, Copilot can actually keep you focused on the code more than having to deal with the external distractions of having to do research. And that research can happen right inside the IDE with Copilot helping you do the implementation. And teams observe more reliable code due to Copilot suggestions aligning with those best practices. Again, a theme is that by taking advantages of AI and Copilot, your code will be cleaner, and then it might be that if you were doing this all ad hoc. And finally, the Accenture case study, Accenture teams reported fewer bugs and improved code consistency and faster onboarding for new developers. Again, I think another major plus. When you're, let's say, if you're a new developer on a project, or a developer working on a new project, working with code that you didn't write and are not familiar with, uh, you would, in the past, you would have to rely heavily on any existing documentation, if there was any, or the experience of other developers that I've had spent time working in that code base. With AI, you can use the AI tools to help you understand the code base without actually having to interrupt the flow of other developers, which has two benefits. One is it makes you more efficient because you're not waiting for somebody to get back to you with an answer. And second, you're freeing up time for the other developers, because they don't need to step in and support you as much as they would have to under previous circumstances. All right, so let's move on and talk about AI assisted development. In this section, we're going to basically we're going to talk about reviewing existing code, uh, generating some documentation, generating tests, generating code for addressing tech debt and feature debt, and then managing change, or how we can use AI to help us more on the project management side of things. Let's go ahead and get started. But first, I want to talk a bit about vibe coding. It's kind of a term of the day. Uh, this was the definition that I got from ChatGPT when I said, "Okay, what is vibe coding?" And it says that it's a natural prompts that drive code generation, not handcrafted syntax. Definitely something I can attest to, that I'd spend less time worrying about syntax, and more time worrying about the design and the overall implementation than the actual syntax itself, which is from my perspective, it's kind of a freeing, from having to worry so much about every single semicolon or curly brace. If the developer focuses on guiding, testing, and refining AI output rather than micromanaging every line, which is pretty much what I just said, emphasizes experimentation and rapid prototyping over upfront design and strict correctness. Certainly, I think it helps with rapid prototyping. You can put things together very quickly, if you have good instructions and good context that you're providing. And the code is often accepted with minimal review, allowing for fast iteration, but again, sacrificing initial structure. So this is, in terms of you see the prototyping of design, rapid prototyping over upfront design, and the idea of sacrificing initial structure. I think this is where developers come in, right? This is where you're guiding the AI and giving it, instructions on what that code should look like, and let the AI fill in the gaps. If you're interested in vibe coding, there was a couple of months ago a Code Presents presentation on vibe coding done right, by Philip Bauer. And if you're there's a link here on the slide. To go, feel free to go and take a look at that as well. So let's talk about what we need to do before we start. So this, I think, is important, because you need to establish a plan and how you're going to go approach this. And I think the first order of business here is you should create a restore point. By restore point, mean is a sub place that you feel safe, that you can go back to that point, and if you have to, and move forward. You'll find that you don't want to work without a net. AI will take you down rabbit holes, one-way streets, bad ideas. Sometimes you just never know where some of the ideas that it's coming from, and so having a restore point, if it gets into a situation where like that, you can then go back to that restore point, adjust your prompt, try again. And I do that quite often where, I try several different versions of a prompt until I can get something that's close. And then once I have something that's close, I can then establish a new restore point and then move forward from there. I have seen it where Copilot will make a suggestion for a code change. You implement that suggestion, you try it, it doesn't work. So you give it the error message that you saw after you ran the code. It makes some more code changes based on that error message. You run those code changes and those don't work either. So you give Copilot that message again. You ask it to, then you go ahead and run those changes, and it takes you back to the first suggestion. So now you're kind of in a endless loop of code modifications. So here, it's a good point where you kind of break out of that cycle, try your adjusting your prompt to give you something closer to what you're looking for. Also, consider branching. Great way of creating a store point is just to create a branch and do all your work on that branch. And then these don't even have to be remote branches. They can just be local branches where you do work, test it out, verify that you're happy with it, and then you merge it into either main or a feature branch and move forward with the code that you've generated. And then finally here, you should have a test plan. This is probably the most important point in that without a way of verifying that the AI code that's generated is correct, you're really forcing yourself into a code review cycle and a manual testing cycle that is going to take a lot more effort to execute. So if you have a test plan, it's good to have as is test automation in place where if you're just making refactoring changes and the behavior shouldn't change, you should be able to run these tests at any point and verify that the code that were generated is going to pass from a as is test point of view. And then you want to be tests for any new modifications that you're making. And you could use a test driven approach where you create the new test and then you code and you ask AI to actually implement the code in order for it to pass the test. So moving on then to starting off with the AI code review, let's take a look at that and see how we might go about doing something like that. So we're going to talk about doing an AI code review. We're going to generate some documentation, generate some tests, generate some code, and talk about managing that change. So let's then look at generating documentation. All right, let's take a look at generating documentation. This section, what I want to talk about here is some simple things around generating comments. Comments in code is I think a bit of a controversial issue. Some people like them, some people don't. But the idea behind this is if you have comments, you can keep them up to date by using Copilot. Then I want to show updating a README file, and again, more documentation that we need to keep up to date, and then generating architecture documentation so that we can, have a picture of what our application is how it's actually built. So let's take a look at these. So first off, let's go into our code. Let's bring up the index file here, which has a create store function. Let's go ahead and just select this, and we'll use the inline editor mode, and we'll say go ahead and add comments to this function. And you can see that it's generated a pretty hefty set of header comments for that actual code, which is good. We can accept that. Now we have those functions. And we can also say, I want to, in here, in the chat window, do something similar, saying create inline code comments for the create store function. And ask it to not just put header comments in, but we want to actually have code comments in the body of the file. And you can see here that it's done something like that. Uploaded percentage, it's still working on generating, so we'd expect to see some more show up. There we go, some additional comments. Here it's added some to the end of lines. And working on this section, there's the comments for the last bit of it. And it should be just about finished now. So it's added the comments, those all look good. And we can say, let's go ahead and keep those changes. And let's just say sometime down the line, we make some code changes to this file. And so instead of saying create those kind of inline comments, we can say update. And say update the inline comments for the create store function. And I think what's interesting is that this will somewhat demonstrate the non-deterministic nature of vibe coding, in that you can never really expect the exact same output from the same prompts or from different models. So here we can see that it's didn't like the comment that it just created, and it's created a new comment to take its place, and updated many of the other comments as well with additional information. So it may be that you like these additional comments, or it needs to update them, or you can settle for a single pass, but you could actually run multiple passes through this and get further refinement in terms of the comments. You can also use different models to apply the same type of things and see what the differences are between the different models in terms of how they interpret the code. So here, this has done all of that work. All right, so let's look at the README file. And the README file, if we look at this, we can see that the README file is nothing but a bunch of to-dos here. And looking at it, it looks just like that this file has existed from this initial scaffolding of the project and has never been touched since. So this is a good opportunity to align the README file with the actual implementation. So we can say here, update the README file, .md file, to reflect the current state of the project. And this again this will require a fairly extensive examination of the code base in order for it to update this README file. So here it's looking at dependencies, it's looking at the project file and the things that are contained in that, looking at the Azure configuration, it's starting to look at the JavaScript, main JavaScript code pieces, and the views that are used, and now it's able to update the README file with that with the additional documentation. So this will take a couple of seconds for it to think about the changes it wants to make. And there we go. So notice that basically the entire initial content has been replaced by a new content that describes the solution, the features, the prerequisites that you need to have installed, the installation of some of those prerequisites, installing the dependencies, creating a development server, and how to run the application, some available scripts that you can use to do various things, the file structure, the technology stack, some instructions for actually running the application and testing it, the Azure deployment pieces, the prerequisites for deployment, how to deploy it to Azure, infrastructure as code, the environment variables for configuring the deployments, etc. So a much better README than the default. And so, oh, look, it kept, looks like 2 lines of code from the existing one. So that's good. And of course, just like in the code comments, you can use an update request to actually update it, issue it whenever the project changes in any significant way. So then that's the README. So let's then talk about generating architecture documentation. Now this is really, I think, cool. When you're coming into a new project, or you're working on code that you're not familiar with, I think it's great to be able to have accurate architecture diagrams to give you a better feel for what the structure of the application is and how it's implemented. So for this, well, let's close down our thing. Let's start a new chat window to make sure we're not carrying over an existing context. We're going to be using agent mode, which is good, and we want to use Claude for the generation. And what we want to do is then say, create mermaid. Diagrams. Let me say architecture diagrams for this project. So this is another activity that's going to require some knowledge of or understanding of what the project consists of. So it's doing similar to what it did before. It's reading the package JSON files, the CSproj, the YAML, the bicep. We could have potentially run this in the same context as the previous example, but I wanted to make sure that it was not reusing any of that context and making it a clean request. So here it's going through the infrastructure as code, some of the JavaScript files. Now it's looking at the pipeline files. It found one of those. And now it's going to create create the diagrams that it thinks are appropriate. This will take a couple of seconds. Now, just as a caveat, you'll see different results with different models when trying to generate these mermaid diagrams. And in many cases, or in some cases, the diagrams will be created, but there'll be issues with white space or some other syntax error within the file that you'll need to address. This may occur here. We'll have to see when we're done producing the diagrams. But the typical approach to addressing those issues is just to copy the error message that's rendered and paste that into the chat window and ask it to fix the problems. And it usually does a pretty decent job at that. So here we see an architecture diagram file that's been created, and it looks like it thinks it's done a pretty good job of creating them. Here's a list of all of the diagrams that it's created. So let's go ahead and keep those and choose to open this in a preview file. And we can see here a high-level system architecture. Let's open this in a new window so we can expand it. So here's a system architecture. It talks about the development environment, the CI/CD pipeline, the cloud infrastructure, front-end application. Oh, here's an example of a syntax error. We'll see if we can try to fix that in a minute, but there's a state management architecture, infrastructure as code, talking about the bicep implementation, the CI/CD pipeline architecture. Here's a component hierarchy that didn't quite make it. Testing architecture, a deployment flow. And so here's some of those key features. Let's go ahead and grab this error message and see if we can get it to fix it without too much effort. And we'll just paste this into the chat window. It already has the architecture diagram as the context. So look, it's congratulating itself. It sees the issue that it created. How great that is. All right, so looks like it's done. Let's go ahead and keep those modifications. If we go back to our diagram. Don't see it reflected here. Do I refresh the preview? There's still this one up here, the component and data flow. And the front-end application architecture looks like it still has an issue. Well, anyway, this is the process that you would go through to fix it. You've seen that it produces quite a number of different diagrams. You can also be specific in terms of the diagrams that you want it to create. For example, for a particular usage, you might want to have a sequence diagram that goes through and talks about how a particular workflow is implemented in the application, and it will produce those as well. All right, so now we're going to talk about reviewing existing code. So the idea here is, let's say we've gotten this new project and we want to be able to understand, what the state of that code is before we start diving in and making a bunch of changes. So So in an AI code review, there's a couple of ways that we can go about this. One I think is good for understanding existing code is using the explain function. So if we go to our code, what we can do here is that we can take a piece of code that we're working on that we might maybe not clearly understand the implementation. We can say, for example, explain this piece of code here. I can bring up the Control-I Copilot window and say, explain, and just go ahead and execute, send that to ChatGPT, and it will then it'll generate for us an explanation of that code. And you can see that it's, that one bit of code produced quite a bit of an explanation. It will go through every single piece of every statement and explain exactly what the pieces of those statements are. And if you're working in an unfamiliar code base, or if I encounter some code that's potentially dense or difficult to understand or difficult to read, this is a great way of breaking that down and understanding it in greater detail. So here's I think an interesting exercise. Let's have it examine the code base and identify code that does not conform with those GitHub instructions. So this could be a really early first step when joining a project, is to add these instruction files as we did earlier. And then we can ask Copilot to compare the code base against those instruction files, and it will then hopefully show us it will show us any discrepancies or things that are inconsistent with those files. So I'm going to clean up my work here. Let's start a new code window, undo all these changes. I'm going to switch to agent mode because I want to see what the thinking is as it goes through this step. And then I want to give it a prompt, which is to examine the code base and identify code that does not conform to the github./instruction files. So let's give that a start. This will likely take a minute or two to produce some output. So let's follow what it's trying to do. Notice that it has found the instruction files here that are in the folder. I do think that Copilot is rather self-congratulatory. It's very proud of the smallest things, and it's even proud of fixing bugs that it actually introduced. So I think that's somewhat amusing. All right, so what it's doing now, it's reading in the process instructions, the style instructions. So it's trying to understand what's in all of these instruction files. Practice its instructions. Now, so notice it didn't read in every single instruction files. It skipped all the C# instruction files because they're not applicable here. And now it's reading in the code of the app. It's starting with an app view, core services, different the sidebar views. So it's slowly going to work its way through the majority of the code base. Reading in the main index files, main.js, etc. All right, so it's now done its analysis, and it's now said that, look, we have a inconsistent coding standards, the view component structure is wrong, TypeScript usage, state management, and on and on. So here are the main things that it's found using options AI instead of the compositional AI API with Vue, JavaScript instead of TypeScript, Vuex instead of Pina for state management, not following recommended file structure, inconsistent naming conventions, suboptimal security practices. Notice it's identified as a security issue. Proper Azure integration features, a lack of those, and then it's an adoption of TypeScript throughout the code base. So it says here the code base into compliance with the guidelines, significant refactoring required to do that. And we'll talk about doing some of that refactoring a little bit later, but you can see here that this is actually, I think, fairly useful. And just as an aside, something that we'll get to later as well, you can add here in agent mode additional steps that you would like it to take. For example, you could have it if your project is in GitHub, you could have it create GitHub issues for all of the findings and populate those issues with details about that issue, and you can easily add things like this into your backlog. All right, so let's just talk about generating tests. In this section, what we're going to be doing is using AI for automating some testing and bug detection. So I'll first start off with generating some unit tests, and then we'll talk about using AI for bug detection. Then I'll finish up with a little talk about how AI analyzes logs. So let's switch over to code. I'm working with a previous stash of some changes that AI generated, mostly because it takes a while to generate these tests, and it takes even longer to iterate through the execution of the tests until they pass. I've not rarely seen it where it was able to generate a test suite that actually worked the first time through. So my process is basically to generate the test and then feed the failures back into the chat in order for it to recognize that there's an issue and fix it. So let's take a look at the README here that it generated. That's a useful piece of code. So it said this is the lead service unit test. It's got 27 use cases in that README in that test suite. It talks about the module structure, the functionality, additional tests that it created, a pretty good overview of how the test suite functions in terms of error handling, logging and debugging testing, and then its current behavior documentation. And it does talk about the mock setup. So running the test, so we can just basically select the command that it's put here and execute that command. And that will run the test. You see that there's two test suites. That's for the index tests and the lead service tests. And there's a total of 45 tests that are passed. If we want to run it with a verbose output, which is nice, we can do that. And what that will do is execute the tests. And I missed that. Ran all the tests. Yeah, I guess so. That's good enough, I guess. There we go. See the two set pass. And so let's move on to generating a bug detection. I'm going to clean up my context here. Let's close down our terminal. Get rid of that file. And what I want to do is have, I'm going to ask AI to do some bug detection. So I have a prompt here that I want to use. That prompt is examine the code base for bugs, but don't fix them, just report your findings. So we don't want, the idea here is that just give us a list of bugs. And we could add up to this prompt that not to don't fix them, just create bug work items for them. And that way it would add them directly into our backlog, and we could then prioritize those defects. So let's go ahead and give this a go. This will probably take a couple of minutes, or at least that's what I've seen it execute in a couple of minutes. It takes a while to examine the code base and produce some output. So it's looking at the JS files and the view files. So if you're interested in other code presentations, the next one coming up is a talk on the Microsoft Fabric presented by Ginger Grant. And so that should be a very engaging presentation. So it's still looking at the code store implementation, looking at the routing and configuration files. It's checking the lead service to look at its implementation. It's looking at the test files to understand what's being tested. Let me check one of the view components. Oh, one of the sides that I think is interesting is that when you're asking Copilot to look at or improve your test coverage, it will, or your tests, it will look at the test coverage and see things that are out of date. And if it sees the code that's not being covered, it will generate tests for that code for you, which is very nice. So here we have, it's looking at the code base for defects. It's got authentication issues, configuration issues, error handling, processing. You see quite a laundry list of issues, like in terms of testing coverage, that it has incomplete test coverage, configuration and security. It doesn't like the way that the URLs are being constructed. And authentication token exposure is also an issue. So it would be a good step to take early on in a process is to ask for a simple query like this and a request like this and have look at the code and report particular problems with the code that can be then prioritized and addressed as part of the technical debt. All right, so how AI analyzes logs. This is I don't have a demonstration for this, but what I've seen, particularly when I'm debugging issues related to back-end service components or pieces of the code that are difficult to demonstrate or write tests for, is that when I have a problem that I'm trying to resolve, AI will suggest adding information into the logging in order to try to debug things. It will actually ask for ask to run commands that will retrieve log information and analyze those logs for you. So it's really I think a powerful tool for troubleshooting as you go through and just work your way through issues. Okay, so let's talk about generating some code. In this section, what I want to try to accomplish is address one of the findings from the reported deviations, implement the same changes using two different models, and then compare the implementations and report the pros and cons of each implementation. So if I was to switch over here, the idea would be is to create two branches, and I've pre-canned some of this work so that we can improve the flow of the presentation. But the idea is that I used a prompt similar to this. Where is our Copilot window? So I'll just show you the prompt that I used, which is basically address the view component structure violation in all view files. Now this component structure violation was one of the things that popped up out of the analysis of the code base against the instruction files, and so what I'm gonna do is ask Copilot to fix those. But what I did was I I asked Copilot to do this twice on individual branches. So for two different models, I used one for Claude Sonnet 4, and the other one was for ChatGPT 4.0. And with the idea that once we had these two implementations, we could go about evaluating them to determine which one of them is best suited for our current situation. So I have those two branches here. There is GPT-4.0.save and Sonnet 4.save. Now, I'm not going to get into the details of the implementations, because actually what we want to do is we want to get Copilot to examine them, report on their findings, and compare them. So we can do that. We have our two branches, and we can add another prompt here, which is so we have two branches. The two branches. Sonnet 4.save and GPT-4.0.save contain fixes for this view component structure violation. Review each implementation and report the pros and cons of each. So I'm asking Claude Sonnet 4, let me run this in a different model from either of those two. We use it in agent mode. I'll get rid of these images, and let's ask the contents of the full code base again, as we did before. All right, so that looks good. And let's go ahead and execute this prompt. So, so it's going to be looking for those two branches. So it's searching for, it's in the right folder. So it's looking for the code base, finding the branch information. All right, so now it's got to a point where it wants to actually ask Git to fetch the origin of these two branches so that it can continue those analysis. Oh, it's in the wrong folder. So it wants to look here at the current folder, and it sees that it's in the Git folder. So it'll generate now a change directory command. So you can see in the agent mode, it's much more interactive. Now it wants a Git status to see what's going on. So it sees that it's on the fixes branch and there's nothing there. So it's like it's taking Git it's taking Copilot a little bit of time to read the contents of the command. Now it's going to fetch the origin for both of them. It's here getting the the branches. So it's satisfied that it can see both branches. Now it's going to start to do some diffs. Here, at first, it's just looking at the files. that have changed. And it's also looking for the files. This was in the Sonnet branch, and now in the ChatGPT branch, it's getting the same list of files. And now it's going to look for specific component changes. So here it's doing a checkout of the Sonnet 4 branch, and then looking at the contents of the files. And now in the ChatGPT 4.0, it's doing the same thing for the same file. All right, so here we're on the Sonnet 4 branch. It's going to do, it wants to get the lead owner's view. And do the same thing for the ChatGPT 4. Get the contents of that file. And it's looking for the sortable header components. So same thing for the ChatGPT 4.0 side. So it's systematically going through and looking at individual files on both branches in order to figure out what the differences are, and in order for it to make a determination about what are the pros and cons. So now it thinks it has a comparison. That's good news. So we'll let this run through, and then we'll come back and take a look at the full response. All right, so it's done with the analysis. Let's take a look at the comparison. So looking at the Sonnet 4 branch, what it likes about this is that it's using a modern compositional API approach with script setup, and implements modern Vue 3 syntax, which is more concise and offers better TypeScript support. It likes the more complete implementation. It contains a fuller implementation of the details like handling API responses, etc. It likes the better data flow control. It also likes the reactive references with ref and react. And then it likes using the async pattern. The cons of this is potentially more code, more comprehensive implementation, more code to maintain, less componentization. Some components contain both presentation and business logic, which could be further separated. Less explicit props interface. Some components might benefit from a more explicit typing. On the ChatGPT 4 side, it liked the traditional view component structure. So it's basically using traditional view component structure with export default, all right, which might be more familiar coming from Vue 2. Killer component names, it likes those. A simpler component structure, less code per component, and better separation of concerns. The things it doesn't like about this is it's not modern syntax, so we're not really updating it to the modern Vue 3 syntax. There's a promise chain pattern rather than x=8. There's a simplified implementation, which components have simplified or stubble implementations that might need further development, and less TypeScript integration. So basically key structural differences, the scripting approach, right? Using modern syntax versus traditional. The API uses, this is Sonnet 4 embraces the compositional AI, where it's in the ChatGPT 4 implementation, it's mixed. Sonnet 4 uses async versus product chains. Proponents and component architecture for the props are more focused on implementations, greater use of slots, and then the component structure. So what's the recommendation? Ideal approach depends on your preferences. If your team is focusing on a modern Vue 3 features, then Sonnet 4 is more future-proof. If your team is transitioning from Vue 2 and prefers explicit component definitions, then the ChatGPT version might be more comfortable. So for long-term maintainability and alignment with Vue direction, go with the Sonnet 4 branch, etc. You also might consider taking the best access of both approaches, the modern syntax of Sonnet 4.say with clear component separation and slot usage of the ChatGPT 4 implementation. So I think this is an interesting example of how you can, implement things with different models and then compare those models and make a determination about what the implementation is. It may be that one of these approaches is better for you at the particular point in time, and you can go forward with that particular model's implementation. All right, so we've done this. We've compared those implementations and reported the pros and cons of each implementation. All right, let's talk about managing change. So in this section, what I want to do is talk about generating a path to production and then doing code commits and code reviews, as well as creating a pull request, all using the assistance of Copilot, and then I'll do a section on issue identification and prioritization. So in terms of the first thing is the path to production. If I go to our IDE, then what I want to do here is I want to run a prompt that says create a CI/CD pipeline to use Azure DevOps pipeline as code to provision and deploy the application to staging and production environments in Azure. So let's run this and let it go ahead and churn on this for a minute. So the intent of this is twofold. One is to actually deploy, start to put together an actual deployment pipeline that'll get us to staging and into production, as well as provide us some code that we need to actually use as a part of our path to production in terms of committing code, reviewing code, etc. So you can see here that it's using the Azure deployment best practices, CodeGen best practices, and just basically looking at what are some of the best practices it wants to conform when it's actually building out this pipeline. So it's looking at the existing pipeline to see if there's anything there that it can use. And so then it's going through the infrastructure as code files that exist, make sure that those are up to date. It's reading in the Azure YAML file, which contains the information on how to connect and configure to Azure. So now it wants to create a comprehensive CI/CD pipeline that enhances what we already have. All right, so it's going to create some modifications to some existing files and some new files. All right, so it's created or updated the pipeline file. So it's created some variables. It's created a build stage for building and testing. A deployment stage to deploy to staging. A smoke test, a deployment to production. And some post-production validation checks to make sure that everything is working in production. So it's doing a pretty decent job of building out something that's comprehensive. It's created a README variable group file that defines some variable groups or describes what those are. It's created a documentation file. or updated a documentation file with some additional information on the pipeline, that it's the current state of the pipeline. And then at this point, it's still working on that README file, updating additional instructions in the README file. Still more modifications for the README. And what's now created a script to configure the environment on the first run. So here's our setup pipeline code. PowerShell script takes in a number of parameters and then goes through each module, installing those modules necessary for to run the pipeline. Logs into Azure DevOps, creates a service connection for both staging and production. Looks at the variable groups, so it's iterating through the variable groups file and setting those up. So this is all bootstrapping the CI/CD pipeline. And then it's finishing this up with a modification to the README file, and it's outputting the output. So this is pretty good. It's done a pretty good job, I think, of creating some files. We don't know if it works, and we won't in this session. But let's do this. Let's change this to a different model. Let's say go to ChatGPT 4.1 and just say review this code. And so this, we can ask for a code review essentially for the modifications that we've made. Now here's our review summary. So what does it think? So ChatGPT 4.1 says the new and update files provide a more robust pipeline with clear documentation, references variable groups for sensitive information, but be even better to explicitly mention encryption and access control for these groups. Uses a what-if validation for the bicep deployments, and then consider clarifying its limitations or prerequisites in the documentation. Overall, the pipeline, setup script, and documentation follow Azure best practices for security, maintainability, and deployment. So all of that looks really pretty good. So let's continue then. And talk about a pull request. So let's go ahead then and say we want to commit these changes, say new mods to CI/CD. We stage them, and let's go ahead and commit them, and then say, let's try this. So here's a prompt. So it says, in this prompt, it says, create a pull request for the last git commit. The remote platform is Azure DevOps. Create the pull request from the current branch. The target branch for the pull request is main, and delete any existing pull requests for this particular set of changes. So I think what I'll do is submit those changes to the branch. Bummer. Let me undo this commit. I didn't mean to commit it to that branch. I wanted to create a new branch and put this in a CI/CD branch so we can further test this. And then we can commit our changes to that branch. All right, that's good. All right, so now let's see, now that we're on that branch, let's change our model back to Claude 3.7. And let's go ahead and then run this request to create this prompt to create these pull requests. So first it's going to look at the current branch. Oh, it's in the wrong directory. So it needs to navigate. So it'll figure that out and go to the right folder. Then it'll ask us to run the show current command again. that tells ChatGPT we're on the CI/CD branch. Good. It's happy that we're on the right branch now. So Azure repos PR list status. So it wants to see if there's an existing PR for this branch, and this, and it looks like there doesn't exist to be an existing branch. So that's good. So it's going ahead then, I think, and give us the command to create the PR. So it wants to make sure they have a remote setup. So it's going to make sure that this is a published branch. And unpermitted changes in the remote. So it's going to push those changes then to the branch. And now we'll create a pull request. So here we see then a command, and as an AZ command, Azure DevOps command to go ahead and create this pull request for the pipeline implementation. So that's good. So it's created the pull request. It's happy about that. Tells us all of everything this did, and I think that we're good with to go there. So the next thing I want to share is issue identification and prioritization. So so the prompt for this will be going back to code. Let's close all of our files down. Clear our context. Let's go ahead and keep the files that it's created. And this is CI/CD, so let's just go ahead and, or mods. And let's go ahead and create a new chat window. So I think we're okay. We can probably then switch to the main branch for this. And what we want to do is we ask it to examine the code base for defects and create bug work items for each finding. I'm going to make sure I say Azure DevOps, because so it doesn't default to GitHub, because unfortunately this project is Azure DevOps instead of a GitHub project. So what this is going to do is then essentially do a review of the code, identify issues or defects in specific that it thinks it needs to change, that need to be changed at some point, and then it's going to then provide us with work items that we can then use to prioritize this technical debt and then so that we can work on it in our backlog. So it's now going through and examining some of the files in the project. It's looking at the lead service files. It's just basically just doing a comprehensive code review. And it's going through all of the view files. So it thinks it's found several bugs. It wants to make sure we're all right. So it's checking to see that we're running the latest version of AZ, running a decent version, and now it's going to create a bug work item for each one of them. So we're going to run this command. It's going to create a work item and go ahead and the URL empty string issue. And if we look at this bug, it's a empty API in the lead service JS. It's a description in the config that's set to an empty string. It's assigned to a severity, which is high, and a priority, which is 2. So it had a problem, so it wants to run this again. All right, looks like we got a work item back from it this time. And now that it has a good syntax, we can then go ahead and create each of those issues. Inconsistent case handling and API responses. We're going to continue since we've been on it for a while. Here is a API URL misconfiguration. Here's an issue on inconsistent error handling in service files. Duplicate function in lead service, so it found some duplicate code. Found a security bug. And severity 1, critical, priority 1. So it thinks that's an important thing to work on first. Authentication system commented out in our router. So what does it think of this one? And inconsistent cases and response priority checks. Missing content type header. All right, so it's found it and it's created work items for all the issues and just reporting back on the issues that it was able to create and what those bug numbers are. So the idea here is that you can add this kind of instruction onto many of these investigative type of prompts and have it automatically create work items that can then go into your product backlog, and then you can use that as part of your sprint planning in order for you to continue to improve the code base. And I think the ability to actually identify these bugs is a really important feature. All right, let's talk about bias management. And basically, my thought on this is that we're trying to keep the AI honest here. Try to recognize what about this. What about things about the AIs that we want to be able to compensate for, or at least take into consideration. One of the things I think is kind of interesting about working with AI to help us develop software is that it's fairly non-deterministic. I mean, it's kind of like it's like a box of chocolates. You never know what you're going to get sometimes when you ask it a prompt. And sometimes when you run the same prompt at different times, you'll get slightly different variations on the output. The content may be essentially the same, but the format might be different, or how it goes about doing the analysis is different. So and sometimes if you're not seeing exactly what you want, you might change the model or change the prompt slightly and see if you can get a different results. So let's take a look at talk a little bit about bias. So first is, what do we mean by bias in generated code? Because when we think about bias in AI, it's come from sources like face recognition, having some bias or some other part of bias, and almost all of that is based on the training data that's going into the model not being diverse enough in order for it to produce I think, a realistic output. Same thing is I think is true for generated code. I mean, it is the code. It only understands the code that it's been trained on. Therefore, if there's a new a piece of code or a new way of doing things, or things have changed since the model was trained, it's not going to recognize those things. So when we mean by bias is introduced in through the training data, it's in the context of generated code. Bias may manifest itself in a couple of ways. One is preferences that for once popular but not obsolete, but that are now obsolete implementations or solutions might be suggested, even though there's a better solution that the AI does not know about. And then it's basically the idea that if you're taking old code and you're writing new code based on that old code, you're just going to get more old code. And AIs are not they don't create things, at least at this stage. They're not going to create a new pattern or a new way of implementing things. It's going to basically guide you through how others have done this in the past. So don't expect anything new. Just and expect that what you're getting from the model is coming from whatever code it has actually been trained on. And some models are better at certain kinds of code, have a better experience with some types of logic. So you just have to kind of pick and choose which ones best fit your needs. So some examples of bias in AI generated code could be something like a hard-coded assumption. So you might have an assumption that everybody in your user community all speaks English, and that would be something that might show itself in the generated code if you're not asking specifically for it to be multilingual, for instance. It could be something like exclusion of accessibility. If you're not prompting it or you don't have in your instructions that it needs to be accessible, then you might see solutions that are generated that don't include those kinds of additional features. It could be a data filtering bias where you're actually restricting your queries to a certain demographic and not being diverse enough in those queries. Or it could be something where you have a bias for a particular language or a particular locale. You could have a bias towards the security vulnerabilities where generated code may overlook some edge cases and lead to security gaps. There could also be functionality gaps where if you're not specifically prompting for a particular feature, the AI will not know to generate it. And so let's talk a bit about how to mitigate bias. First is one of the things, as I mentioned a couple of times, is a multi-model generation. Play these models off against each other. Have them review each other's code, and particularly you can ask it to review for specific kinds of bias, and that's an effective technique. Always take a look at your and do regular audits of your code, looking at AI generated codes for signs of bias, both manually, and there are automated tools that can actually help you with that as well. And then, of course, we always want to have a second pair of eyes on our code that have a human looking at that code and looking for those kinds of biases as well. Moving on then. Last is future considerations. So here, what I want to talk about is just where we stand and where we think we might be going. So the first is the evolving role of AI in development. So it basically started out with the chat window. You're asking it to solve certain problems in your code. It's evolved into where we have an edit mode where the AIs can actually modify the code directly, and then into these agent modes now where it can take more sophisticated actions on the behalf of writing better code, and we've seen I think some good examples of that. So if you think about it, generating code is a natural for an AI because it's code that's trying to write code, and I think it's one of the most widely used uses of AI is using it to generate code. So more than writing term papers, I think there's a lot more use of it right now being used to generate code. Also, the models and the tools are improving rapidly. It seems like every time I open up Visual Studio Code, there's a UI change or a feature change or a new model available or the like. And so it's a kind of you can see that the pace of change is very fast, and that there's a great deal of competition to improve these tools, and so you can expect them to get better and better over time. Um, so then the next thing is AI engineers versus AI engineers, which is redundant in a way, but it isn't in the sense that we start out with an AI engineer, a human AI engineer being somebody that either develops models or uses models in terms of developing solutions. There's now a concept or a truly AI engineer, which is essentially fulfills the role of a human engineer in that it can pick up a work item, it can evaluate or plan a solution for addressing that work item, it can implement that solution, and it can verify that that solution is correct through test automation. And why this kind of AI engineer is not quite there yet. This is where I think the the industry is going, is to make these agents more and more and more sophisticated and capable of assisting development in even better ways. So the last is looking at it from the other side. What is the evolving role of development in the AI world? Which is how is our activities as a developer changing in this world of AI? We kind of alluded to this earlier when we talked about the old cycle of code, fail, research, code, fail, research, being separate processes, so using separate tools. Here, now the AI is much more involved and more directly involved in the development and in testing and evaluating it, focusing more on the AI than the external resource tools. So finally, the idea is vibe coding actually coding? And my take on that is, well, if you've got good instruction files that are ensuring that your code is conforming to your standards and practices, and you have a strong test suite that can verify when you make a modification that everything is working as expected, then what else is there that you need to consider to actually take that code and put it in production? And my take, that's a pretty decent bar. If you can meet those criteria, I think you're ready to try that code out in staging and verify it in production and move forward. All right. So in conclusion, what I think is that you have more control over this generated code than you might expect. Between all of the different ways we talked about today, you really have the ability to fine tune this output for your particular situation and get it to do what you expect it to do. Um, let's talk about just some best practices for integrating AI tools responsibly. So you want to do code reviews, and as I said, you can do these code reviews manually, and you also automate them through the use of different AIs. Um, test code reviews. So this is, I think, particularly important. When you're generating AI tests, you need to review and comment on those. You need to review those test code because you want to make sure that your tests are solid before you start to making code changes. You take advantage of this review and comment capability where it'll look at your code and suggest modifications. Use these instruction files and keep those instruction files updated, and then evaluate your code against those instruction files regularly so that your code is so that you know what the state of the code is versus the state of the art. And then you can use those if you find discrepancies, you can use AI to create work items for you so that you can address those deficiencies in due course. And then on the prompts, I just wanted to reiterate that all of the prompts are in the slides so that you can go back and try them on your own. None of them are too sophisticated. I think they're all pretty straightforward. And I'll also include a zip with the instruction files, which you could use as a starting point for your own set of instructions. Just wanted to point out that I'll be speaking at the Next Gen AI conference in October in Orlando, and I keep checking my blog. You'll be able to see new content on a monthly basis there. And don't forget about Code, who are sponsoring this presentation. Code is a custom software company, a staff augmentation company. They publish Code magazine and do training like this webinar and other training sessions. So visit the website at codemag.com for our information on all these different activities. We would appreciate if you would fill out a survey on this session. There's a link here and a QR code that will get you to that survey, and one lucky survey response will receive an Amazon gift card. So there's an incentive to do that. And then the QR code on the right is for a free 1-year subscription to the digital version of Code Magazine. So take advantage of that. And then finally, some QA. I'll be happy to take your questions. And you can reach me at the email address on the screen, and there's some links to some existing resources that you might want to take advantage of. And thank you very much. On to questions.